Hi, my name's Stewart Lynch, and in this video I'm going to be showing you how you can choose to persist your application data to your documents directory in the typical JSON format, and also as MarkDown using a Swift package called MarkCodable. As you will see, there are some real advantages to being able to view and edit your saved data as MarkDown. I love getting your feedback, so tap the thumbs up button if you enjoyed this video and leave a comment below. Make sure you subscribe to the video and ring that bell to get notifications of new videos. And if you want to support my work, you can buy me a coffee. There is a starter project for this video, and I encourage you to download it from the link in the description and work along with me. In the end, you'll have some code that you'll be able to use and refer to in the future. First, let's see what our project looks like. So I'm going to run it on the simulator. It's a very simple app that lets me add families to a list. By tapping on the toolbar button, I can create a parent by adding the first name, the last name, along with a city and province or state. Once that's done, I can choose to add one or more children. And each time we save the form, our list gets updated. Let me just add one more parent with only a single child. You also have the ability to swipe to delete one of the children, or you can tap on the trash icon beside the parent's name to delete the entire family. The big problem here, though, is that when I stop and then rerun the application, there's no persistence. Nothing gets saved. So before I get into the two different saving techniques I want to introduce, let me step you through the code so that you have a basic understanding of how the app is coded. The family view is the view that's presented on load. And this is a list that loops through the list of parents that it has access to from the data store that we'll get to. And there is a header view that is used to present the name of the parent along with their address, their city and state or province. And there's a button that will allow you to delete that parent from the list. The children are the actual rows in each of the sections, and they're presented in a for each loop. Above each loop is a button that will allow us to add children. And the swipe action is there to delete them. There's a button on the toolbar that will allow us to add new parents and thus families. The form used to present the entry, either a parent or a child, is a sheet using a medium detent, so it only comes up partway from the bottom of the screen. And I'm using an Enum to present the appropriate sheet content, using a technique that I go over in this video. So I'll leave a link in the description if you want to check this out. Our objects are in the models, and for this project there are two, a parent, which is identifiable, and an address, where the property is an address object. The new entry view is that medium detent. If we are adding a child, we present only the first name, but if we're adding a parent, we include the first name and the last name, as well as the address field. I have a computed property here that will disable the Add button until all the fields have some text in them. The entity enum is what is used to display the appropriate content in the view with either a new family or a child of a particular parent. And since it conforms to the view protocol, this will also provide us with the corresponding view for our sheet. Again, I encourage you to review that video that I mentioned earlier. And then the final piece where we'll be doing all of our work is the data store. And as you can see, there are two published properties for our parents and for the presentation of our sheet. The parents is an array of objects, and it's initially empty, so no parents in the list. And that optional entity enum type is what we'll set to present the new entity view. And then there are four functions that handle the creation and deletions of families and children. Well, there are many ways to persist data in your projects. You can use core data, or Realm, or some cloud source like CloudKit or Firebase. However, if your needs are simple, you can save your data locally in a single file in a format that you can read from and decode to populate your data. The traditional way to do this is to store your data as a JSON object, so that's where I'm going to start, and then I'll move on to the alternative that you may wish to consider. In order to save your data as a JSON object, you'll need to make sure that your models conform to the Codable protocol. In our case, that's as simple as making sure that each of our models conform to that Codable protocol. And this is possible because each of our properties are strings, or an object address where each of its properties are also strings. And since strings are codable by default, the entire struct will be codable if we specify that conformance. Next, when we create a function in our data store class, that will allow us to save that encoded JSON to our documents directory. So let's create a function called save. As I'm going to be doing both JSON and MarkDown saving here, let's start with a comment for JSON. Next, since encoding and saving can fail by throwing an error, we can start with a do catch block. In the do block, create a constant to represent the document directory, which is url.documents directory, and then we can append a path using the string family.json. So the name of our file will be family.json and stored in the documents directory for our app. Next, we will encode and create a data object called parents data by trying to use the JSON encoder to encode our array of parents. Once we do that, we can try to write that parents data to that JSON URL. Now, if either of those tries through an error, we can catch it and print the error's localized description. Now that we have that save function, we want to add it to each of our 4 existing functions where our data changes. Let's test this out by running our app once more, and I'll speed through the process of creating the same 2 families with the parent and children as we did in the demo. Now, I want to see what that saved document looks like. And in order to do this, I'm going to return to the app's entry point where app main is and create an onAppear block when we present our family view. Within that block, I can print out that url.documentdirectory.path. Let's run once more. After loading in the console, we see the path that's printed. If I select that path, I can right-click and choose Open. After confirming Run Service, we see our app's documents directory with our family JSON file. I can right-click and open this file in TextEdit and see the JSON object. Now, it's not really easy to read, and editing it is fraught with error possibilities. But I'm getting ahead of myself. I have a solution. Now, when that app is run, it's not loading the families from the JSON file. So we'll need to create another function in our data store to do this. So we'll create a function called loadFamilies. And I'm going to be creating 2 versions here again. So the first one is going to be for the JSON, so we'll create a comment. And we'll need to get that same URL as we used for the save function. So let me just copy and paste it in here. Next, if that file exists, we're going to decode that data. So first, we can use a file manager function called fileExist at that path, which is that JSON URL, that path. So if it does exist, we can create another do catch block here because getting that data from the file and decoding it may throw an error. So we'll let the JSON data be the result of trying to get the data from the contents of that JSON URL. Then we can assign to our parents array the result of trying to use the JSON decoder to decode that function on an array of the parent type, so .self, from that JSON data. And again, if it failed, we can catch the error by printing the error's localized description. So when do we want to load our data? Well, we want to load it when our data store gets initialized, which is then injected into the environment. So we'll create an initializer here, and then within the initializer's body, we'll just call the load families function. So let's see if it works. I'll run the app, and then yes, after loading, the data from the file is decoded and our families array is presented in the section list. And I see I can swipe to delete to remove on the children, or I could delete an entire family if I chose to do that. So let me just stop and run again. And I see that update has persisted. Perfect. Well, the big problem I have with the JSON here is the ability to make changes to that file, or even to read the contents so that I can get a picture of what my data will be like in my app during my development stages. Now, this is why I want to introduce you to MarkDown and a wonderful SwiftPackage by Maren Todorov, who is iCanZilb on Twitter. As an iOS dev, you should be familiar with MarkDown, as all of your GitHub README documents are done using MarkDown syntax. It's a wonderful way to generate text documents with some standard formatting. Now here's a reference to the basic syntax. I'll leave a link in the description. But the extended syntax gives us access to much more, specifically tables. In raw MarkDown, a table looks like this, which is pretty good. But when it's rendered in a MarkDown application, it looks like this. Well, there are dozens of MarkDown editors available to you, and personally I use Typora. Originally, while it was in beta, it was free, but now it is a minimal cost. But I think that it's well worth it, and I have an entire video on how I use it. And I'll leave a link in the description. It allows me to enter and view rendered markup without having to learn the syntax. There is a free version that's pretty similar to Typora called MarkText that you may wish to consider. And the easiest way to install it is through Homebrew. It's pretty good, but as you'll see shortly, Typora has a distinct advantage in our use case. Anyway, the reason I'm showing you MarkDown here is because there is a package by Maren that we're going to install, and it's called MarkCodable. So to install this package, all we have to do is copy the URL link, which is in the description, and return back to Xcode. From the File menu, choose Add Packages, and then paste that URL into the search field, and add the package. We only need the first of these two options, the MarkCodable option, so choose it and click on Add Package. So instead of saving and loading from a JSON file, we're going to update our functions to save and load from MarkDown. So the first thing that we'll need to do then is, in our data store class, is import MarkCodable. Let's work on that save function first. So I'll comment out the code that we have, but keep it here as a reference. Our MarkDown, though, is going to be pretty similar. So let's have a comment for that MarkDown, and we'll need a do-catch block as the process may throw some errors. We'll want to create a MarkDown URL so that it will be in our URLs document directory, but this time we'll append to our path the name family.md, where MD is the MarkDown extension. Then, instead of using JSON encoder, we'll use Mark encoder, and this will produce a string instead of data. So we can let parent string be equal to the result of trying to use the Mark encoder to encode our array of parents. Then we can try to use that parent string to write to the MarkDown URL with atomically set to true using UTF-8 encoding. Then, as before, if it throws an error, we can print the localized description. Well, before we test this, let's update our load families function so that it will load the MarkDown instead. So, as before, let's comment out that JSON code, but keep it around for reference. And add a comment for MarkDown. We'll need that different URL, so we'll just copy and paste it from our save function. And then the first time our app runs, there won't be any such file, so we'll use our file manager class to see if the file exists at the path of that MarkDown URL. Then if it does, like our JSON decoder, this could throw an error, so we'll need to create a do catch block. Well, we know that the Mark encoder encodes as a string, so we can create a MarkDown string variable by trying to retrieve the string using the contents of that MarkDown URL. Our array of parents then will be the result of trying to use not the JSON decoder, but the Mark decoder to decode the array of parent object type from that MarkDown string. If either of those tries throw an error, we'll catch it by printing the error's localized description. Well, let's test and run. The app loads, but our families are missing. And that's because we're no longer reading from the JSON file. There is no MarkDown file yet, so we've got an empty array. So let me quickly recreate those same two families as before. I'll speed up the video so as not to waste your time. Let me stop the app now and open that documents directory again because that path was still printed out to our console. I see that family's MD file now. And I'm going to open it with my MarkDown editor of choice, Typora, first. And here we see our data is presented as a nice table, and it's very nice and clear and easy to read. And I can even right-click on a row and add a new row to the table. How about the city being Denver and the state or province being Colorado? Let's give our parent two children, Bill and Jen. And our parent's first name is Sally. And then for the ID, because I just used a string as our ID field, I'll just type in any random string. And for the last name, I'll use Patrick's. Well, let me save this and minimize it. And I'm going to open that same file once more, but this time in MarkText, the free MarkDown editor. And you can see it looks very similar. Well, let's run our app once more. Notice that Sally Patrick with the two children? Great. It was added by my updating that MarkDown file. Let's delete one of her children. If I bring up that Typora file once more, we can see that that MarkDown has even been updated. And this is great. I can update my app and see changes in the MarkDown file as I go. If I return to my simulator, let me add another parent, but first without any children. Again, you'll notice the MarkDown file is updated too. If I add a child, we see that entry has added as well. Unfortunately, with MarkText, those updates are not appearing, so that's why I prefer Typora. You may get different results from different MarkDown editors. That'll be your choice. If I switch back to Typora, I can toggle between the source code and the rendered output. Even the source without the rendered output table is still pretty good and still readable. Now, unfortunately, we don't have any notifications going back to our app to let us know that there are updates. So if we delete a row in our table here, it won't get reflected in the app. And that is until we stop and start again when it gets a chance to reload the data. So MarkCodable is a really good option for storing flat single-entity content like preferences or simple data like this. If you refer to the MarkCodable documentation, there's a discussion regarding relational data that you may wish to refer to. For me, when that data gets more complex, I find I have greater needs, so I then move on to core data or realm for persisting my data. Anyway, that's it for this video. I hope you've learned something here that you can use with your own projects, and you'll be able to make use of what you've learned. If you like this video, please give it a thumbs up and leave me a comment. Be sure to subscribe to my channel and ring that bell to get notified of new videos I post. Thanks for watching.